Yeah, exactly.
Alright guys, we'll get started. I'd like to welcome you all to the first ASHRAE meeting 2016. Happy New Year to most of you, and I guess we can welcome the winner so far. I'd like to start by introducing the board of governors and the executives. Richard Cameron, Board of Governors. Chris Frawley, Board of Governors. Aaron Dawson, Board of Governors. Chris Fudge, I don't believe Chris, I saw him here.
I can miss him.
Yeah. Adam Moons, I don't believe is here either, Board of Governors. Dan Redmond, Secretary. Adam Graham, Treasurer. Abby Saunders, President-elect. Steve Moon, past President. And I'm your President, George Mawari. I'd like to ask Dan Redmond to come up and introduce the guests.
Thank you, George. So tonight we have Mark, and actually I should apologize beforehand. Mark Olin, Mark Delorier, Kevin Quinlan, Darren Trentholm, and Michael Lowman. Thank you.
Thanks, Dan. Both of our membership chairs are not here today, unfortunately, couldn't make it today, so I will announce the new chapter members that joined OVC since November. And again, I apologize if I'm mispronouncing names, but we've got Terry Yakub, Andrew Morris, Jameson Wood, James Patty, Kristen Jackso, Brandon Zagrodnik, Sarah Gilani, Bisan El Farah, Jason Jerling, and Anthony Mack. A couple announcements before we get to the dinner portion. We've got two upcoming seminars. One is ASHRAE sanctioned. I'll start with the one from MCA. We've got one coming up from MCA. It's on Tuesday, February 9th. It's on fire damper installation and kitchen ventilation, NFD 96. It's from 8 a.m. to 4 p.m. taking place at the Centurion Center on Colonnade Road. If you are interested to register, please go on the MCA website, or you can find the link in the January communique. We also have our ASHRAE seminar taking place on Tuesday, March 15th. It's a seminar that Judy Jeske will be hosting, and she'll be going over the new NBC versus the OVC and interpreting the changes. That will be taking place at the Master Group on North Side. So it's a half-day seminar, and the cost for members is $150, which really isn't much, and I think it's going to be very beneficial to a lot of our chapter members. Next, I would like to ask Joe Del Valle to come up. Our theme for the night is Yay. I'll ask him to say a few words.
Hi everyone. Just want to give you a recap on what we've done so far this year and where we're going. We've done two YEA events. One was a pub event where we were downtown on Rideau Street, and Adam Moons had his band there, and it was quite the event. And then we had an event at Tailgaters, and it was very well attended. We had probably about 12, 15 people at any given time playing pool, talking, playing different foosball or whatever is going on in that type of event venue. We're going to do another event like that in February, I think. So keep your eyes on the announcements or event communique type things. I'll be putting something out again in January for a late February event. Two other things. The YEA leadership thing that I did back in September. There's going to be another one of those events coming up, and every time that those come up, I really would like to see applicants from our chapter. It reflects well on us as a group to have lots of applicants. Same with the leaders event, which is where YEA member would then go to, this time it would be the summer conference, and they would sit in on society meetings, and they would be all expenses paid. We didn't do too well with getting applicants in for the first one, so this time I really want to make an effort to get a couple applicants in. I spoke with my chair, or sorry, the person above me, and we're going to try and make it a PAO points for this, so that if you apply, then we can do better as a chapter in the tallies at the end of the year. I'd like to thank everyone who's helped me so far this year, and if anyone has any questions about how they can help me out or volunteer to become part of the committee, let me know, and I'd be happy to have you on my team. Thank you.
Thanks, Jim. Another announcement, we have our upcoming curling bonspiel coming up in March. There's a slight change from the normal way we normally, on the day we normally have it. It normally occurs on a Friday. This year there's been a lot of changeover at the city and at the European Sportsplex, so unfortunately they forgot to reserve the date for us on Friday. So the curling bonspiel is going to take place on Thursday, March 10th, starting at 1 p.m. There will be a link posted on the ASHRAE OVC so people can register. It's $380 per team, and we've got 8 sheets of ice reserved, so a total 16 teams can register. There'll also be an ad in the next communique, so look forward to that. Also want to mention Abby's got going around selling some raffle tickets for 4 tickets to Ottawa-Toronto on February 6th, which was generously donated by Engineer Air. We are doing great on the RP campaign. We still have long way to go to meet our objective. So if you haven't bought your raffle tickets, please do so. These raffle tickets really do contribute a lot to us obtaining our objective. Last thing before dinner, we've got a few tabletops today. We've got train. I'd like to get someone up here to talk about the tabletop.
Hi everyone, my name is Mike, and I'm doing a tabletop today on train controls. So feel free to stop in and talk to you guys about anything that's train related or even train equipment. So again, thanks, and my business cards are there as well if you'd like to talk. Thanks.
We also have a tabletop from Johnson Controls. I think I saw him leave. I'm not sure if he's still good. He's good there, right? His loss. And lastly, we've got Larmex here with tabletop. Just got Pat. I got Pat, ladies and gentlemen, if you guys remember him.
Thanks, George. Just to correct George, it's KMC Controls. Thanks for that.
No problem.
But in essence, KMC has developed a new IoT thing, so we want to have a tabletop here to support Intel. Intel and Dell are backing our hardware and our software to help us provide you with an Internet of Things solution. So come by the booth, see me, and you can ask me any questions you want. Thank you.
With that, we'll get going with dinner, and following that, we'll draw the tickets for the raffle and get going with the program. So, enjoy your dinner.
When I show up, am I going to talk to you? I'm going to go look at
All looks the same.
I'm taking water. Yeah, I swear to God, water treatment is a very interesting course. I've taken 2 courses, like 2 classes, and both of them I was just glued to everything he was saying. Was just interesting. I didn't know much about chemistry going into it either, so it was kind of a refresher to do it, but it's a pretty good course. Like the guy talks about all the different types of cooling towers,
Well, you know,
how to treat all the different systems, and he's just kind of, he's a good friend. He's been
Good, everybody. Hope everybody enjoyed the
he knows his
meal.
stuff.
Before we get on to the evening program, 2 things. We're going to do the draw in a couple minutes, but first I'd like to ask Don Weeks to come up, talk about the Orlando meeting that's going on, the ASHRAE Orlando meeting, or sorry, the ASHRAE winter meeting going on in Orlando this week.
Don, can you clarify that for us? What's that? I'm sorry? Can you clarify that for us?
Verify that I'm going to Orlando? Yes, I am going to Orlando. I'm going to Orlando to ASHRAE meeting. And of course, if you're going, it's a great time to be going to Orlando. It's a little chilly outside here. But really what George and I talked about earlier was that one of the things that goes on between now and February 16th is an invitation to all of you to join one of the technical committees or one of the standing committees for ASHRAE at the international, national level. This is a great opportunity that many of us have taken advantage of over the past, but I want to invite anyone who hasn't taken advantage of it to take a look at some of the technical committees that are out there and see if there'd be something that could be of interest to you. And the way this usually works is that you get an interest in it. You might approach myself or George or someone else that has been involved in the ASHRAE for a number of years and say, listen, would you be willing to nominate me and name for the president-elect, which is Tim Wentz, professor from Nebraska. Once you do that, he will make a decision whether or not this is the individual that should go onto these committees. It's a good process, and what I would say is that it's a really fulfilling process, and it's something that I think all of us should do at one point in our careers, is consider doing something at that level for our profession. And so if you're interested, look at the technical committees. They're on ASHRAE.org website. Either approach myself or approach George and let us know that you're interested, and we can see if we can get you nominated for it. So thank you very much, and hopefully see some of you in Orlando. All right, George, thank you.
Thanks, Don. Wasn't your miss. All right. Last thing for the program event, the draw for the center tickets, we were able to raise $660 towards ASHRAE research. Thank you, Engineer, for bringing full tickets. So I'll ask Abby to come up. Take your tickets.
Well, you get the honor.
Wow.
Pick a good one. You did?
Yeah, then I can't wait. Perfect.
You didn't want to go anyway.
I didn't want to go.
Forced him.
All righty. 240-3450.
Oh.
There he is.
Oh.
Are you kidding me?
Prodigal son.
He never shows up to meetings anymore.
The prodigal son returns.
Archie.
There should be a law about that.
Hey! Look at this guy.
All right, so on to our program theme. So we've got Andre Beauchamp here today with us. He's the Sales Development Manager over at Install Canada. Here to talk about the Internet of Things. Andre is responsible for the Intel sales to the system integrators, embedded and communication customers in Eastern Canada. So I'll let Andre come up here. I'm just reading this off the communicator.
Very good job.
All right, thanks, Andre. For those of you who want the copies at the back, so I'd ask you in the next couple of minutes if you want some coffee to get up and get it right now.
Are you going back
A coffee, please.
Yeah, exactly. Usually the smell.
Great, thank you.
Just put you in the mood, we'll play a little video here. All right. Can everybody hear me all right? Yeah. This is good? Don't need a microphone, right? I hate microphones. Okay. It sort of ties you down as well. So I'm Andre Beauchamp. I'm located here in Ottawa. I've been at Intel for a very long time. I'm not going to say when I started, because I normally get, I was 3 years old then, so I'm not going to go there. But one of the things we were talking at the table is, how old is the iPhone? When was the iPhone born? You can't look it up on your iPhone. What year?
2006.
What was it? 2000, June 2007. So that's how new this is. And when we're talking about the Internet of Things, there's a lot of communication, right? Everybody connected and all that good stuff. So this is not all that far away. So this is all new technology. And what I wanted to do today is just talk about Internet of Things, or IoT, as we all know it. Some call it Internet of Everything, some call it Industrial Internet of Things, but basically it's all the same thing, it's all Internet of Things. What it is, what the market is like, who's sort of participating in that market, which is pretty well everybody. And then I got some user cases we'll go over as well. during the presentation. And I'm open for any questions at all about Intel, about anything that you want to talk about. I'm open for that. But essentially, the first slide is, what is the Internet of Things? So we're starting off, obviously, the things sitting at this end, and the things have been around for a long time, right? This is nothing new. You guys are very well aware of things out there because that's what you do day in and day out. You put things on roofs, you put things around manufacturing sites and so on and so forth, but those things are not connected. That's the only difference. Now, you could argue that's not true. They are connected, machine-to-machine connection. But the problem with machine-to-machine connection, as we know it, has been around for a long time, is a proprietary connection in between the machines. So it can't get off from that particular environment. So it makes it a little bit more difficult to gather the data that you like to use. So that's where Internet of Things starts, is what do you do with this data? That data is there. How do you get it out from there? That's when we're now started moving into the network. Now we're going to start talking about gateways. We'll define what a gateway is. Gateway is a lot of different things to a lot of different people. There are a lot of different definitions to that. Talk about the network. We're talking about what's Cisco doing in this environment, or even some of the telco, the Alcatel-Lucent, the Cienas, all those guys who are in the communication space. What are they doing in that space, in the communication area? And then we're going to move everything over to the cloud. So why do you want to move all this stuff to the cloud? You need to bring everything to the cloud. And you bring all the intelligence that resides and all the data that you're collecting in the things, you move all of that stuff up to the cloud. Well, if you do that, it's going to take the whole network down to its knees because the network is not made to handle that much data, right? So where do you have intelligence? And that was, going back to the video at the end, was intelligence. That's got to come out here. That's what we mean by intelligence. That intelligence now starts coming down into the things, from the cloud to the network to the things. So what are we looking at? 50 billion devices. Everybody's been talking about 50 billion devices for a while now by 2020, or depends on whose report you read. The years will go up and down. Nobody knows, right? I mean, a device can be a phone. A device can be something that is in a mine. It could be something that is stuck on a cow. It could be something that's in an HVAC system, and so on and so forth. Now, one of the things that is interesting in this whole thing is that the cost of the sensors has gone down the 2x over the last 10 years. So the things are becoming cheaper, more prevalent in different markets. We're looking at the cost of bandwidth, and we all know where that's gone, right? I mean, just look at your internet bill today compared to what it was 5 years ago. Forget about 10 years ago. 5 years ago, it's a lot cheaper. You've got a lot more data and so on and so forth. Unless, of course, you're on the Rogers plan, but that's we don't talk about that. And then the cost of processing has come down, they're saying 60 times over the past 10 years. If you look at just the Intel processors, just for fun, 1985 is when the 386 was born, 375,000 transistors. Today, the 6th generation, you got about 2.5 billion transistors. That gives you more computing power, right? And if you go back even further than that, you get the PE11 and all that stuff. Huge, lots of power and all that. That cost has come down drastically over the years. I got no idea if I'm talking about all the stuff that I've got in my notes here. But, the zettabyte. Anybody know what a zettabyte is? So if we'll go back to the gigabyte, because everybody knows what a gigabyte is, right? So a gigabyte times 10 is 12. So yeah, it's lots of zeros, right? So you were saying how many terabytes? So a terabyte is equal to 10 gigabytes, and then a petabyte is equal to 10 terabytes, and an exabyte is equal to 1,000. Yeah, goes on and on, right? So another interesting fact about the network and the cloud and everything. So today there's about 2 billion smartphones in the world, right? So on the 2 billion smartphones, on average, you have about 26 apps. At that point, in a lot of places where I've sent that, people take out their phones and start counting how many apps they actually have on their phone. Right? You don't have to do that. But on average, that's what it is. Each app will do about 20 data center transactions per day. 20 transactions per app per day in the cloud. So that means 1 trillion daily data center transaction is done just by smart home. Tons, and that's why the data part of this is so big. And that's why these data centers are going up all over the place, right? The Azures and the Amazon web services, and you just go on and on and on about, you know, how much capacity there is out there. A lot of people are saying, well, what is it being used for? Well, there's an example, one example. That's just the smartphones. So this is Intel's view of the different market segments or verticals, but it's pretty well, the whole industry is looking at pretty well the same way. So we've got retail, we've got the transportation, the manufacturing, industrial and energy, we got the broad market, and I can explain that if you want to, and then we got the smart homes and smart buildings, and that's essentially where you guys fall into is, well, you sort of fall into 2 categories, right? In the smart homes, smart buildings, but also a little bit in the industrial and energy. Would you agree with that? That's my guess. The quick conversations ahead of time, right? It's sort of interesting because you look at that and you're going, okay, so that's the whole Internet of Things, so which sector has gone faster than the others? It's always the ones that are a little bit easier, so low-hanging fruit will grow faster than the others, obviously. Here, what we've seen is retail has really taken off quickly. Because in that, you have things like digital advertising or digital signage, which is pretty quick to get up and run. I mean, essentially, it's a PC with a big display, you've got a bunch of software on it, and bang, you're done. And if you can save a store, whether that store is a small mom and pop store or Sears or Walmart, you can save them a couple of bucks. They'll love you for it, right? So we'll talk about a great example around that later on. Transportation is sort of interesting because you have, okay, who has not seen, because I think everybody's seen the ad for the insurance companies for a car, and if you put this gizmo in your car, then you can save up to 25% of your insurance and all that stuff, right? And we've seen that. That's IoT. Because what this thing is a little device, it's got a little computer on it, it's a microcontroller, and it sits up, it's bolted into your car, it's communicating with the cell towers all the time, giving out data. It's giving out a load of data. But the only data the insurance company is interested in is how fast you're going, how fast you're stopping, a couple of other things. There's 2 or 3 things you're looking at, and that's it. But there's a ton of data coming out of these things. So transportation, there's probably millions of devices that have been installed already on things as simple as what I've just described. Now, there's the other part of when you start talking about transportation is the larger trucks, which can save tons and tons of money on gas. And I got an example of that later on as well. Obviously in your industry, if you can save someone a few bucks on energy, that's a big deal. That's a huge deal because buildings are big and everybody's trying to make them more efficient, and you guys are involved in that market. Again, we'll have some examples of that. But that's essentially the market the way we see it. So smart home and building is small, but the industrial one and energy is huge. There's a lot of money saving. And it always comes down to that. What's the savings? Why should a company invest in new technology other than saving money at the end of the day? So, I just put this together today. So essentially so things to the cloud, the first stage is, and that's what we started working on last year. And when I say we, it's not we as an Intel, it's we as the industry in general, because we're all pretty well at the same starting point, and we're all trying to work together as it'll become more apparent in the slides as I go through them, is that this is not, yeah, I speak for Intel, but it's the industry in general that is moving that way. So the last few years is essentially connecting the unconnected. Right, so all these devices that are out there, make sure that they are connected so that we can move on to the next stage. And that is not as simple as what you may think. Right, so you live in the city or you have the large buildings and all that stuff, all of this stuff is all connected. But when you start getting out, if you start going out to, if you start looking at mines, if you start looking at agriculture and things like that, connections can be an issue, can be a problem. So how do we do these things? How do we make a standard for all these communications? We're talking at the table about home automation. yeah, there's been all these companies that came out and you can control your lights with this little gizmo, and then the company goes out of business, and well, what do you add to that? Well, it wasn't a standard, it never was a standard, so you're left with something that doesn't work anymore. So standards become very important in this whole discussion as well. Then the next stage is to start connected things, so integrate computing power and devices, could be your smartphones, could be whatever, in order to run these devices. And then how do you do this software-defined autonomous world where now you're getting into the cloud, you're doing the analysis of the hardware, but not the hardware, the software that you're pumping up, all the data that's coming up. How do you make sense of all these bits that you put into the cloud? So essentially, it's vertical strategies, which I've identified before, right? So there's a few verticals, horizontal platform and products, and then a strong ecosystem. So that's what is going to make a winner out of this whole IoT thing. So think back now, okay? So I had the multiple segments, right? And if you have to go horizontal, if you don't do the horizontal thing, because about 60% of platforms and solutions can be reused in each of those segments. Okay? If you don't do that, then you're going back to the days of the IBMs and the PDP-11 and PDP-8s where they had a stack and then they did everything. So IBM did the OS, did the software, did the application, did the hardware, did the whole thing. So they were vertical. The PC industry came around and did slash this way. Right? So it could be used in multiple segments. It could be used everywhere. So that's what we want to do. We want to carry that philosophy over into the IoT segment. And the strong ecosystem is what's going to make it appealing. So we spent a lot of time on this. This is I love this one. It's used inside of Intel more than it is inside. But you know, where are we in this IoT market, right? So you have the unconnected, legacy embedded. You've got the Kia phone. You're looking at that going, what's that? I've never seen one of those. And then you got the BlackBerry, and then you got the smartphone. So it's nothing against BlackBerry. It's just, you know, it's not an iPhone, right? It's not as easy to use. It's not as well connected a little bit. So if you're looking at where we are in this graph on the IoT, we're about 1.2 or something like that. And I think I'm being generous. Is that, you know, we're starting to connect stuff, but we're not quite that far up the hockey stick towards the heel of the hockey stick, right? So we're all in the same category, we're all doing the same thing, and I'll get into the example with the HVAC, how we're doing and what we're doing in a few slides. This was a sort of an interesting slide as well that I want to show you guys is, you know, the maturity phases. And this is all, you know, the sales and marketing type of idea. When you enter into a new market, what do you have to do? So again, you have to connect, you have to secure. So that's essentially the two phases that we've gone through in 2015, where the problem that we're seeing is the amount of work that needs to be done in order to get through the first two phases. Is a lot more than what the industry thought in general. And so for that reason, it's taking a lot more time. Then you get into the third phase when you start to analyze and manage the data and add security to it. Security has got to come really early into play here. I'm not sure if this is where I'm supposed to be talking about that or not. I can't remember where I put my note on this, but there's a couple of examples where security wasn't thought out by major companies, and you know, you can think of Target, you can think of Home Depot, right? They exposed, I can't remember how many hundreds of thousands of customers on credit cards and emails, and the case study around Home Depot is, you know, any thief knows that if he wants to enter a building or a house, he goes into the weakest place of the house or whatever, a dark area, go into the dark area where nobody can see you for a couple of days, and once you're inside the house, then you can do whatever you want to. So essentially how they entered into Home Depot is a weak point into the IT infrastructure. So they had security everywhere, right? The point of sales were secured. The whole IT infrastructure was secured, all the PCs and all that stuff. They had these pretty complicated passwords they had to go through. but unfortunately, the weak point was the HVAC systems. So the HVAC system was reported to the IT. The password protection was not there, and they got in that one. So once the hackers got into the IT system via the HVAC control systems, they were in the house. Once they were in the house, they were there as long as they wanted to because nobody knew they were in there. So they could do their dirty task, their dirty work, and just put the head So security becomes a huge deal, right? It's going to be everywhere. It's going to be at everything. And how do you make sure that the thing that is communicating to the next level is really the thing that it says it is, and it's not a intruder who's trying to get in? That's all of these things that need to be thought out. And that's why these two took a lot longer the two first phases took a lot longer to realize. As you go up, then we start hitting the benefits of the IoT deployment. Now if you get to the stage where you're starting to predict how the devices and processes perform and take action, now all of a sudden you're getting into the HVAC system doing its job, but now taking away all the uncertainties that you had before. So instead of going on every 3 months to do a check on the HVAC, then you only go when it is necessary to go in and all that good stuff, right? So it becomes a whole different type of environment, whole different type of job, and then you optimize. And that's where the ROI comes back into the company, is you reach that last level, and the profitability starts going up in all the installations that we've seen in all the areas that we've talked about. All right, so this is sort of going back to what I mentioned, the verticals and the horizontal platform. Again, if you look at the verticals that we mentioned before, and in the middle what you have is this reusable integrated building blocks for faster time to market, which is ideal, right? You need to have a solution that is being copied here and there so that you can get time to market very quickly. The trusted application, again, you need that security level to be in there, all the way from the edge to the cloud. We'll talk about the middle in a second, the gateway. A lot of the security resides and sort of looks on both sides of the equation. So the information coming in from the thing and the information going to the cloud, and how it protects the whole middle. Of course, standards-based, open and scalable products. I mean, if you close the architecture, it's going to kill the market because you won't be able to afford a product to give you an ROI at the end of the day. And then a consistent developer experience, and we've seen that with things like in the OS world with Linux, right? So Linux is pretty well pervasive when you start talking about embedded systems, whether it's a company like a Wind River or a QNX, whichever way you would pronounce it. They're all Linux-based, and that is really an open system, an open platform. So very, very important. To me, one of some of the jobs I've been involved in has involved this ecosystem of partners. We talked about what's a partner, what's an ecosystem, what's the relationships between the different people, and there's a whole slew of logos here, and they fit into different categories. Some of them fit in multiple categories. Either you're an IoT equipment builder, a provider, a solution provider, and that solution provider would be like a system integrator, but beyond that. So you have companies like Accenture, who would be a solution provider. You have the tech providers like Dell that Pat mentioned earlier as a good partner. Right? So all of these guys are all in there forming this ecosystem and all have a piece of the action. And it's very important because this one company can't do it all. The other thing that's important is, and we're talking about, is the standards of the industry. And without the standards, everybody's going to go off on their own and do their own thing. Now, when I always like to come back to a very simple standard that came out 20 years ago, USB. I mean, who doesn't know what a USB thing is on your PC? Right? USB is universal. Come on. So the way USB started off, it started off in the Intel labs, and then we started looking around going, okay, if we're going to make this on the PC, everybody's got to buy into this thing. And I remember 20 years ago, they used to have these USB fairs, I think they call them. And what it was is manufacturers of different things, like mouse, printers, whatever peripherals you wanted to hook up to the PC, you would come to this fair and you would try to hack at the USB port to make sure that it was good for absolutely everything, to replace the serial port, the parallel ports, the PS2 ports, the whatever other ports that we had in the back of the PCs before. And when this whole thing started, that was the first one that I paid a lot of attention to. There were companies coming into this consortium and say, well, hey, I've got some IP I'm going to bring in. I'm going to bring in some patents. But at the end of the day, I want some money out of it because it's my IP, it's my patent. So I'm going to charge you, 5 cents per. And Intel said, no, you can't do that. This is going to be, you're putting in time, you're putting in effort, you're putting in your IP, the whole bit. It's got to be a freebie right up front. You're protected, but it's got to be a freebie. Otherwise, USB will never take off. And no one was going to pay $5 for a USB add-on to your motherboard. Because everybody's PC industry, right? Cheap as much as you can. So it had to be done that way. So everything that we have driven since, like these two consortiums, driven being part of the founders team, has always been, no one charges for their IP when you come into this thing. It's going to be a freebie. Very, very important. Okay. So two of them were formed. One is the Open Interconnect Consortium, which is more oriented towards, I'll say the home, although it goes beyond that. And then the other one is the Industrial Internet Consortium, which is more of what you guys are involved with, right? So you've got a whole slew. They don't mention all the members in there, but there's the Dells and the GE in the Industrial Internet Consortium is one of the co-founders, one of the big ones who's really involved. But there's a slew of companies that have gotten involved, and there's 215 plus members and 100 plus members as well. So again, driving towards standards, very, very important. No standards, not going to make it, right? So ecosystems and standards are what make the whole thing go. I mentioned the gateways. Remember, you've got the things and you've got the cloud, and somewhere in between you've got the network and a gateway. So the gateway thing started off with, remember, I mentioned the machine-to-machine thing first, right? So a whole bunch of different buses. You guys probably are more aware of those buses. So you know the machine-to-machine buses, industrial buses. Yeah, and then there was another one. This is too stupid. Yeah, and it's way in the back of my mind now. I can't remember those. But there's a whole slew of those buses that were made for whatever industrial usage that you were involved in. So now you get all these things out there that have this weird bus. How do you get that easily connected into a gateway that will then send it off to the internet? So over the more common interfaces that we know, Wi-Fi or Blue Wire or whatever. So the original designs of the gateway, essentially what we said, we'll make essentially a little PC type of idea. We put a whole load of these different buses on it, so we can plug whatever there is out there on it, and then have a little bit of intelligence, a little bit of manageability, and a ton of security, so that whatever comes from the things will not then move on to the next stage on the network, into the servers, into the cloud, as you start to do your analysis of your data. All right, so very, very important to do that. Now, what's grown out? Again, that was phase one, was making this PC gateway. And a gateway can be anything, right? A gateway is it collects data from something and it pushes off somewhere else. It can be a PC, and I'll show you an example of someone who's using Core i7 PC, or it could be a Core, which is a sub-atom component. It could be a small ARM. I think there's one, the cheapest one that I know of, the micro gateway, would be a device that actually resells for less than $5. So not based on a digital processor, none of that. But it's got a little bit of intelligence, a little bit of security, a little bit of manageability, and away it goes, right? So it can be anything in between that and the Core i7 PC, which is probably, I don't know, 3 or 4 grand, depending on what you need. Some of them have made gateways for specific markets. Right? So in the HVAC systems on top of roofs will be a gateway. Right? So it started off with a pretty clunky gateway from Intel. Now it's somebody else who's making it based on reference design. So again, what we've done is we provide a reference design so the rest of the industry can take whatever they wanted out of the reference design and build their own gateway, whether it's application specific or vertical market specific or whatever. But again, it sort of goes around the standard. What we just announced, and the companies at the top are some of the partners in the ecosystem that make gateways. You've got companies like Advantech, Aon, probably some of the guys that you may or may not deal with, not familiar with. So they're more oriented towards the truly embedded marketplace than the compute marketplace. And then in the middle you've got Mom2, which is a Linux, Wind River, which is Linux, and Microsoft that will bring a lot of manageability and all that good stuff. So depending, Dell is another member of that whole organization that make gateways. So let me read the definition, the latest definition of the gateway. This is a guy from the factory. So give me a definition of what a gateway is. So a gateway unit is an industrial PC or edge appliance that's described by the vendor as a gateway. The device sits between a data producer, a sensor-enabled legacy endpoint equipment or IoT-enabled equipment, whatever, and is performing a data aggregation function. And in turn, is also performing a data analytics control application function, and is passing the data results to a hierarchical set of analytics and control systems, or is performing some closed-loop control automation function, and is doing so securely over networks. That, by definition, it is a gateway. So it's pretty wide, right? It's got to collect the data. It's got to do something with it. It's got to be secure. Right? So, what?
You stole my money. I think I'm out of my depth here.
Uh-oh. Okay. Let's take the time out then. Is this cool?
It's just me.
No. I've been like talking like 100 miles an hour a year, and I tend to get really excited about all this stuff. And it's not apparent at all, is it? So, okay. Yes? No? Good? Bad? You following me? Yeah?
Sort of.
Thank you. You're being honest. Okay. So let's go back then. What questions? I love questions because slides are fun, but questions are a lot better. You got a question? As you're thinking about your question.
Just to see if the analogy is correct, is a gateway basically like a home router where it takes information, moves it from one hand to the other,
Yeah.
back to the center?
Yeah. Basically, it takes information, does a little bit. Sometimes it'll manipulate. So again, that's why the different types of processors come into play, right? So if it doesn't do very much to it, then you just send it off and you get a microcontroller. But if it does some analytics already, then you'll want a more powerful CPU, and it'll set it off to. And when I say it'll set it off somewhere else, it'll either set it off to maybe more of an enterprise setup, so maybe you have servers on site, or maybe you just set it off to the cloud and do the analytics in the cloud. The reason you want to do that is if you take all of the sensors and you send it out to the cloud, you're going to bring the whole network worldwide down, right? Because you got 50 billion devices trying to talk to the cloud. It ain't going to happen. So yes, a router type of idea.
The thing that we run into in this industry a lot is you get a lot of equipment with unitary control. So then there's a thing called lawnmowers or backpack seems to be and it seemed to be the device or box or case that you feed so that you can talk to different pieces of unitary control from a central location.
So that would be
Elaborate that.
So that would be more of a machine-to-machine thing, right? Because if I got that, I got that right, that's more of a closed environment. You're not using
But
it.
it's going to a front end, and we have a gateway to the internet, so you can talk to all of
Okay.
them.
So then you have a closed proprietary network, a gateway in the center of it, which goes to the cloud and the analysis. So there's nothing wrong with that, right? Because now what you're doing is you have the things collecting the information, and then at one point or another you have some calculations going on, you're doing some analysis, and then hooking up with other networks.
So the backend device, a component that allows it to talk to a different type of, I don't know if it's a language interpretation in an internal
So that would, yeah, so you have the gateway would be to take care of the physical connection, but also there would be some APIs, so it would recognize, so that would be your software interconnect to what you're talking about. So that's where a solution provider would come in. And so that's this whole ecosystem, right? That solution provider would come in who's got some expertise in understanding the software that resides in your network and then the software that resides beyond that. So how do I talk from your software that's been around for a long time to the API, which now communicates with us? That's, again, part of the gateway's functionality. And again, it depends on how much intelligence is required in the gateway in order to do that. Yeah. That make sense?
Yeah, it's just a different issue. For example, you've got your Honeywell, your Johnson, big control company out there that you have to do that. Then you have your manufacturers of equipment that have military controllers on. And somehow the larger control system have to communicate with the unitary controllers depending on whose system it is, you know, to some lesser or greater degree, will communicate with operators. So they're not full.
Yeah. So that's why this
It's a different, sounds like it's a
Yeah.
different.
So the IoT thing that we're talking about is not something that's going to happen all morning. It's a journey, right? It's a long-standing journey. And
Just to clarify on that is that nowadays Dell and Intel have developed an actual call it portal, whatever you want to call it, and it actually clips into any Jace on the market. So any Jace, doesn't matter if it's Honeywell, Johnson, Distech, KMC, whatever it is, it's all going to plug into any Jace, and it is actually designed to communicate flawlessly on the Niagara sort of platform. So on top of the Niagara platform, it'll also hook up to the network of your building. So it'll take into consideration all the building automation system, your lighting, it basically is a cheap device to turn your building into a smart building. And allows you to hook in your fire alarm panel to it as well. Bring in your card swipe key cards, hook it all up, program it to your personal cell phone so that it follows you wherever you go. So the new the systems that Intel and Dell have developed, and there are other competitors out there as well.
Rayon, Advantech, you name it.
It's ASHRAE, I have to mention them.
Yeah.
But basically they hook into any Jace and it's flawlessly. You really have to understand how it works, because if you plug it in without really putting your parameters and your standards, your whole accounting will go up to the cloud instantly, like ours did. But there are ways of preventing it. You just have to understand. It was a test. We were just trying it out. But you really have to understand the programming behind it. So you can really limit as to what information is released and what information comes in. So depending on the client or the owner, they want to have their key performance indicators, such as what's my carbon footprint for instantaneously? Is my building using too much energy? Am I up to my peak levels or whatever it is? It informs the people instantly of the performance of their building, depending on what they think is important. And the Internet of Things gathers the information through the actual devices, as he says, the solution providers. And then solution providers sends it out, and this cloud correlates all the information, sends it back down to the proper person, and says, here is what you've been looking for, and it updates it instantaneously. So you have a live performance of your building, your business, your accounting, everything.
So that's what this gateway is. So it sits in between the system and the new system. That's
Thank you.
No problem.
That's great. It brings everything together. All right, that was my presentation. Thank you. So the importance of gateways. Okay, I'm not. Well, this is just a rematch a little bit of what we just talked about, right? So you got the things, and the things can be any sort of sensors, right? So some sensors are very low cost RFID. Some sensors are a lot more expensive. Some reside in motors. Some reside in cows. Some In agriculture, it depends on what and you would describe some of the sensors that you're looking at and collecting data from in the HVAC environment. And then on the so this is, one of the routers. So you got router in my head now. One of the gateways exposed here, so you got analog going in, 232, 435, does that make sense? 485, exposed to Ethernet and so on and so forth, right? So all the different modules, the 2G, the 3G, and all that good stuff. So a whole bunch of different standards that are pushed into it. Okay, enough gateway talk. So I wanted to put this up because one of the questions we always get, so Dell's got a gateway, Aeon's got a gateway, and all that good stuff. A whole bunch of companies have a whole bunch of stuff. But what happens if you want to go back and go, hey, what I want to do is I want to set up a little lab back in the company. I really want to understand what IoT is all about. How do I get started? Right? Is there like an SDK, a system design kit of some sort? And that question was asked over and over and over again. So we finally came out with this Grove IoT commercial development kit. I told you I would sell it. So I don't care if you buy this or not. But more and more companies will come up with things like that, right? And I think that's the neat thing about 2016 is that more companies are going to start coming out and saying, hey, I do have an IoT thing I can sell you depending on what you're doing. Right? So this is an easy way, plug and play, up and running, hooked up to the PC. You've got, with it, you've got a whole bunch of connectors, a whole bunch of little sensors and stuff like that, so you can develop stuff lab. And if you've got a very specific application that you're working on, or a very specific problem that you're working on, you can use this kit to simulate your environment, or actually hook it into your environment and do something with it. And if you're satisfied with it, then make a product out of it and away you go. So that's that, and I can't remember how much it is. It's pretty expensive. I think it's like $300 or something like that to get up and running. So it's a cool way of getting in. The other thing we were talking about, the other thing we're talking about, if you haven't heard about it, Maker Faire, hackathons, you heard about these things, right? So then you've heard about Arduino, you've heard about Raspberry Pi, and all that good stuff. So our answer to that, Raspberry Pi is Raspberry Pi is a small processor that they use. I don't know which university it came out of. I think it's MIT. It's in the Northeast, I think. And very cheap. I think you can buy a Raspberry Pi basic compute card for like 10 or 15 bucks or something like that. This one's a little bit more expensive. But you got a bunch of connectors around it. The idea behind the Maker Faire or the hackathon is you register for these things, and there are kids that are 10, 12 years old who register for things like that, and there are 75-year-old people who register for it as well. And it's like Legoland. Think of Legoland with electronics behind it, right? So they'll invent something on the spot. And the neat thing is that they'll have some of the experts walking around the room. So Intel's put some hackathons together at the University of Toronto and in Montreal somewhere, I can't remember where. And they'll have about maybe 15 engineers walking around helping people with their projects and stuff like that. And then they judge the projects and give a prize away. But the intent here is the more of these things that are going on, the more of the IoT thing that goes around, the more data we can collect, the more neat projects are coming out that will take advantage of all this intelligence that is out there, all these intelligent connected devices. So if you haven't heard, it's Maker, M-A-K-E-R, Faire is F-A-I-R-E, or Hackathon. Either one, look it up. There's magazines on this thing. It's really cool stuff. And some of them will be attended by fairly senior individuals from companies because they want to see what's going on with the kids are building. And there are some kids who have actually sold some of the designs to companies and have been hired. Next hackathon, you got to be there. Was that? Yeah. So yeah, that's really cool to follow and get involved in. Okay, well, I'm not going to go over this. Okay, case studies. So there's a bunch of them. I'm not. You guys are the experts in HVAC, and Pat described this perfectly on the one that had the logo. So it's different verticals where, so what we've done is we picked different companies to work with. And I was explaining during dinner, sometimes it's not really scientific how we pick the companies we want to work with. Often it's because we have a relationship with them, maybe they're selling to us. I'm sure the HVAC manufacturer, I don't know that for a fact, but I'm sure that's the one that's on top of our roofs in Chandler, in Arizona, where the IoT group is based out of. They probably went, hey, it would be cool to do that. Let's phone George at this company, bring him in and see if that works. And then all of a sudden, the two companies got together. And so up till 2016, that's the way business was being done. And what we need to do is we need to kickstart the solutions that are coming out. So let's work with one company in a market segment. Let's do a project together. Guaranteed at the end of the day, no one's going to make money out of this project. We're going to have so many resources, it's going to be so much touching going on in this thing that it's impossible to make money. But it's going to permit us, our company, to put together a solution brief, an architectural design of what we've done, and then it can be copied by others to do exactly the same thing. So eventually, some of the best known methods being used in that particular HVAC system could be used in other industries as well as by other manufacturers in that industry and copied. So we've done that. All right, so we've done that for multiple industries here. One that is, and Nexcon is one of those manufacturers for the embedded market that does gateways and things like that. But here, very similar again, we work with them to do more robotics and more intelligent robotics, gathering the information from the robots in our own fabs. And if you've ever seen a fab from Intel, it's one of these major clean rooms. They have to wear money suits. Before they go in, they have to go through the vacuum cleaner thing, and it's about 100 times more clean than an operating room in a hospital. Right? So if you have less people in the clean room, then you have less chances of having dust and things like that. So that became a big deal. So now we've worked with them, made this manufacturing brief and architecture, and being made available to others. The other cool thing was with Levi's. Again, in retail, there it's, if you read the inventory distortions, a $1.1 trillion problem worldwide. Those are big dollars. So what does that mean? That means that on day one after they've done the inventory count, they're at 95% accurate. At day 30, they're at about 65% accurate. Right? So then they start over again. So every 30 days they have to do this. Now, the loss can be attributed to a whole bunch of things. It's either lost inventory, stolen inventory, misplaced inventory, you name it. Wrong inventory on the shelf. Right? So the Levi's thing is, it's a store in San Francisco we work with, and we've got all these gateways everywhere. They've got RFID identifiers on all the clothes. Now they can tell exactly where that pair of jeans went from there, was picked up by someone, looked at, put it back, or was it taken to the dressing room, tried on, and put back, not box, or why within the box, or maybe the sizing is wrong or whatever, maybe the inventory is wrong, maybe they need more 505s instead of 506s or whatever, and then how many actually made it to the cash and how many made it to outside but not through the cash. So the accuracy went from being horrendous to being somewhere around for the 30 days. I think it's somewhere in the 80, 85, and we haven't even gone to the full analysis of everything. So working very closely with Levi. So on the retail side, huge amount of money that's being saved on that. On the agriculture side as well, if you can tell, from the weather or from the health of your livestock before they get ill or whatever, then you can improve the product that comes. So it's dairy, cows, or meat or whatever. And then these guys are pretty interesting as well. So there's this whole system going on to collect more taxes from people who are not paying taxes.
Hack them.
I mean,
Hack them.
security is really big there. Really big. So yeah. All right. So you've talked about this, right?
I recognize that.
You recognize that chart. So we worked with Pat on this one. And I'm not the expert in this stuff, so this is what essentially you talked about?
Yeah.
Yeah. There we go.
That's the one.
That's the one. So, again, the briefs on this are all on the Intel website. You can download this stuff, see exactly what the environment was, and what Intel and this company worked on as a solution. I missed some of the and so, again, HVAC, large HVAC company, that's probably the system that are sitting on top of our Chandler sites. We worked closely with them, incorporated some intelligence into the rooftop HVACs. Then you got your IT, the gateway that would collect the data from multiple units on the desktops, and then shipping it to the cloud and doing all this performance management, the asset management. They developed an application that runs off of tablets, and that's sort of a picture of one of the screens on the efficiency of the HVAC system. They were talking about, well, if you know if it's going to be warmer in the next couple of days, then maybe you can cool the temperature of the building earlier as opposed to cooling it on that day, so it's a softer, you guys know what that like, right? So you raise the temperature over a longer period of time as opposed to give it a boost right away, so you save energy on that. If there's more things in the air that maybe you need to replace the filters more often, less often, or whatever, so that it becomes a more efficient way of working on the systems. And what they found is 60 to 70% lower energy costs, lower maintenance costs. And one of the companies that we work with as well decided that that was our sole business was manufacturing this, the maintenance of these things. Now what we can do with the additional data that we're collecting is now we can add another service portion of our company where we can collect some more money for the data that we have. At one point or another, someone's going to figure out that having the data, you become the king of the universe. Because then you can partition that data, you can sell it, you can form companies out of that data that you have. It's going to be very interesting to see what happens there. And I think in that environment, building management, efficiency of the buildings, when you're talking about between buildings and stuff like that, this is going to become very, very a big deal in this, right? Because there's so much data that you can collect and play with. This is on the transport side with Vinomics, again on the large transport. So they've got tablets in. So now what you're taking away is the driver's going to fill in all the logs and all that stuff. All the logs are all done on the tablet when he comes in. It's all automated. He doesn't have to waste time. So your driver can concentrate on driving as opposed to filling in a piece of paper as he's driving. I don't know if they do that. I'm just saying. And then the other thing they've done is put some driver training into the tablet, so depending on the weather, depending on the incline, decline of the road that he's on, what gear should he be in order to be more efficient. Over a very, very short period of time, they save millions of dollars in gas, because that's the only way that they can save any money, right? I mean, the cost of the truck is the cost of the truck, the driver's a cost, those are all given costs. The only thing that varies is how much gas you use, and they save millions of dollars in the first year. That they did that actually 50 billion gallons of fuel annually, a saving 7%, 38 million tons of carbon dioxide, about $25 to $30 million a year that they're saving in installing a system like that. So pretty interesting. Oops. Skipped over my favorite one. GrowSafe, Calgary-based company. I call them the Internet of Cows. So essentially what they have is, they're based out of Calgary, but they've got a global footprint. They have these devices in the ears of the cows, and essentially like a small RFID. And what it does, it collects a couple of data from the cow, so temperature, over time, all that good stuff. When the cow comes over to the feeder, then it downloads information. And from that, they do an analysis. So their gateway is the Core i7 PC that sits in the barn, and those are pretty big barns with all the feeders and all that stuff. and it collects the data, then they do a analysis of the data. So in the old days, they could tell that a cow was going to be sick. I think it was like a 3-day window, 3-hour window. 3 hours, my cow's going to be sick. A cow is sick, then the milk is sour. I lose X amount of milk, and so on and so forth. With the system and the analysis they can do now, they got 3 days. So now in those 3 days, what they can do as a feeder is maybe dump more antibiotics or change the diet or something. The other thing too is that they find that the cow weighs too much, then they can reduce the amount of feed. And if you reduce the amount of feed, less comes out. There's probably some good news there as well. So you've got, individual farms, and then the data is pumped up to the cloud and analyzed along with other global farms, companies, and those are units. But yeah, very successful in what they're doing. So that's a really cool example of a very simple way of putting together a company to do this. This company is 12 people big. So it's not a huge. They don't have a huge R&D department. They've got maybe 5 guys working on this. So essentially, and this is not just an Intel thing. It's really the ecosystem at large is developing and producing smart connected things. The product portfolio becomes important. The reference architecture becomes really important. And in the reference architecture comes in all these partnerships that we've done with companies where we've developed a particular application for a particular market segment that can now be replicated elsewhere. Okay, but again, if it can't be replicated and is scalable, then nobody's going to make any money out of it, including the ones. Very, very important. So I'm just going to leave this slide up. There's a bunch of links here if you're interested in one of those links on some of the IoT stuff that goes on inside of Intel, but often, as I said, there's a whole bunch of briefs. Yeah, you can take a picture of it if you want to. And, there's a whole bunch of briefs and white papers and case studies that are explained, partners that are gotten together. So not just companies that we work with who want the product for a specific market segment, but also the partners who buy it, whether they're software partners or hardware partners, regardless. That's the boring part of the presentation, not the questions. That's the fun part of the presentation. Yes?
With the 50 billion devices thing, I've been hearing for years that IP4 is going to be an issue, it's going to flood. It's like Y2K, but for the internet. How's that going?
That's a whole different subject, because it goes back to, if you don't have gateways taking in the things in, then you have more IP addresses for all the things. So if you have an IP address for the gateway, then it probably not as bad. But yeah, that's got to be addressed. I don't know where it is actually in the development, but that's part of. You can't have all the devices looking at the side. It's going to kill everything. So it's going to be some compute in between the thing and the track. It's going to be convergence of data. But yeah, sorry, I can't. I know what you're talking about, but I don't have. Oh, come on now. Oh, it's the internet event. No.
What do you think about the possibility of smartphones eventually developing into more like a sensor type app space for individual buildings and also for across the whole area that we might be visiting at any particular time?
Hey, there's so many sensors built into an iPhone today, right? And a lot of those technologies are being brought into the sensors that we're using because of the volume of the iPhones brings in the cost of those sensors. Hey, the phone is already connected. It is a device. It does calculations already because it is a smart device. Yeah, I'm sure there will be apps for that. Yeah, if you remember the little video that I played, right, there was a lot of communications between what looked like a phone and a cell tower and things like that, right? So a lot of sort of related, not really related. And if you go back 5 years ago, there were a couple of companies like TomTom and Garmin that were doing really, really well. I'm not sure they're doing all that well now because everybody's using their phones for GPS, right? So again, that becomes Internet of Things. That becomes a sensor in a way that is taking over from something else. But yeah, absolutely. I think that is a great way because now you can also tell, you know, again, looking at the building, looking at the HVAC, if you follow the traffic via the phone as people are coming in as opposed to an ID badge or something like that, then you can tell when people are entering the building, exiting the building, do your graphs, and look at, okay, so what temperature should your building be at, where the elevator should be positioned in the building and all that stuff in order to maximize traffic, but also maximize your revenue from the buildings. Yeah, absolutely. That's a great data collecting device, yeah.
One of the things for us also is to collect the comfort and the health of the occupants. So let's say that all the phone in that corner of the building seems to show temperature that's too high, so then the HVAC in that particular side can be started. So that's more the application that we're looking at for personal sensor on people's phone and things.
Yeah, no, that's a great example. That is a great example, yeah. See, are you listening? See, they need an app for that.
Yeah.
Start writing apps. But I don't know why I'm thinking that. Comment, question?
There's just so much in my boat. I guess about security, I guess. Like, I know a lot of companies, if they're, like you said, gateways or security, right, the cloud. How do you think they keep up with this? Because obviously, you always hack it, it's hacked.
Yeah. So there's two parts to your question. One that you didn't ask and one that you asked. So the one you didn't ask is, right now when you think of security, you need intelligence in order to make it secure. Like, like a McAfee and Symantec and all those things need to run on a CPU of some sort, with an OS of some sort. Now your things sitting out there, whether it's a CAL with an RFID on it or whatever, doesn't have enough intelligence to run McAfee on them, right? So how do you make that thing communicate with your gateway secure? Well, so what happens is that in your gateway, you'll have a table that will say, I can communicate with you, you, and you. And now I'm getting data from this guy knowing, I don't know who you are, I'm not accepting your data. Right, so that's the type of security that goes on with the things. So there's, pardon me. Uh-oh, I'm thinking I'm in now. So that's one part of the security that's really important. And then on the other side, so.
Like an addressable device.
Yeah.
It's like a wireless or addressable fire alarm system. So that way then, a device that's not has a assigned address recognized by the central panel.
Exactly. Exactly. That's exactly it. That's the security with the thing, right? Now the next level of security that we're talking about. So that security by itself is a conversation that we're going to have for the next month. It's really, really heavy, and it depends on where you get hacked. And there's so many different places you can get hacked. And we're talking a little bit about that before. Is that there's always a space in between the software that prevents the hacking and the hardware that eventually gets hacked. And if you can get the hardware as close as possible to the hardware to hack, then the software doesn't realize that the hardware has been hacked. Right? So that's the biggest issue, the biggest problem. So Adam told me not to say things like that. So that's Intel bought McAfee not 5 years ago, 5-some years ago, right? And so big deal, McAfee's McAfee. Put it on your PC, so how does it address what you're talking about? Well, with all acquisitions, it's a 5-year period of time where you have to leave things alone. 5 years is over now. And what we're starting to do is incorporate some packet security into the system. And hack into the system. It's inside the chip. So that was always the intent behind Intel buying McAfee, whatever number of things. It's not because we wanted that device. It's because we wanted expertise. Now what you can do is, as you know, someplace in there I had like, the Xeon, the Core, the Atom, the Core, Curry, and all that stuff, and those are getting smaller and smaller and smaller. And on the Curry, which is the smallest one, you can't really run an OS. You can because it's in your phone, 6 times. You can run an OS, but it's not going to be in an environment where you want to run an OS. So what you're going to do is you're going to see Curry Silicon, which is going to be a system on a chip. So that means that you're going to have a CPU and a bunch of stuff, all the silicon, including the security. Now you can't get into it. So you can't get into the hardware. You can't have credits. So that's the ultimate security. That's just starting literally today. We just said that's our first product. It's embedded in, it's embedded in a Core i5 in a vehicle system. But manageability is also it's a great question, because you know what comes up a lot is on the health side. Also the cars. Remember there was the Jeep that was hacked, right? That wasn't too long ago. Okay, so all these driver cars and all that stuff, people can hack into it and just do whatever they want with them. There's going to be a level of security. On the health side, why can't someone hack into your pacemaker and sort of be done with you, right? So all these things become, yeah, I had those questions about a year ago from another presentation I was doing, and this, she was a nurse, wow, she knew her stuff. Like, well, you could do this, but you can't do that because this is what's going to happen, bang, 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 bang. But we weren't there yet, so now I would have much better. No, I'm just getting going here. I'll take it from you. You have to ask.
All right, well, if there's...
That's it?
Well, I think
Give him
it's
another
an
half
interesting
hour.
presentation, but I think it was, a lot. Steve did it.
Stretching us.
Well, no, exactly. It's a bit beyond what we normally see on our day-to-day business, so.
But it's where you guys are going.
Yeah.
You don't have a choice in this. This is where you are. In 2 years from now, you guys are going to be, talking with Pat at his level about, the type of stuff that you guys are installing on a daily basis. And it's going to become a software thing, interconnected thing, and the whole bit. I think so.
Thank you. Thank you.
Cool. Great questions. I really appreciate the questions. A lot of fun.
So that's it. The rest of you guys are still here.
I want more.
You will be getting an online survey if you haven't already got an email. You should be getting it by tomorrow. Please take time to fill it in. Gives us some feedback, right? With that, see you on February 16th. Those are going to Orlando. Have a safe trip. See you February. Thanks, guys.